Hi, welcome to this video. This is just the start of organic chemistry. We'll look at a bit of nomenclature, which should be a bit of a revision of what you've done at GCSE. We're just going to go over that anyway. And what we're going to do is going to create 3 tables just to give us kind of the basic information that we can then apply to different structures and try and be able to name them. So the first table we can look at is going to look at the homologous series. We'll look at 4 different types of compound. These names should be familiar. We're going to have alkanes, alkenes, alcohols, and haloalkanes. Now, each of these has got their own specific general formula. An alkane, CN, H, 2N plus 2. What that means is if we had 3 carbons, then we'd have 2N plus 2 hydrogens. So for example, propane, C3H8. Alkenes are CnH2n, and the same thing happens if we have, say, 4 carbons in an alkene, we'd have 8 hydrogens. Alcohols are CnH2n plus 1, and then an OH, and that's what makes it an alcohol. And then haloalkanes are CnH2n plus 1, X, where X is our halogen. So chlorine, bromine, iodine, any one of those. Now, each homologous series has got its own rule for naming then. So alkanes, all alkanes finish ane. Alkenes all finish ene. Alcohols all finish ol. And haloalkanes actually, rather than have a suffix, they have a prefix. So for instance, we'll get chloro if we have a chlorine compound, fluoro if we have a fluorine, iodo if it's an iodine, and bromo if we have a bromine. So depending on what X is, you get a different prefix for it. And that's the homologous series, and then the 4 different compounds we're going to look at. Now the next table we need to look at are the prefixes we use for the length of the carbon chain. What we do is carbons in longest chain. So we do get side chains, and we don't count the side chains when we're looking for the longest chain. We'll have a look at some examples of these after I've done this, and we'll go up to 9. So if it's just got 1 carbon in its longest chain, it gets the prefix meth. So for instance, methane, you may have heard of as just 1 carbon. 2, F, 3, prop, 4, bute, 5, pent, 6, hex, 7 is hept, H-E-P-T, 8 is oct, and 9 is nona. So we'll have a look at some examples of these. So in a compound, we had four carbons, all single bonded to each other and then surrounded by hydrogens. Carbons in the longest chain have 1, 2, 3, 4. So this would have the start bute because it's got 4 carbons in its longest chain. It's an alkane because all the carbons are single bonded and there's no other functional group attached. So this gets the name butane. If we get a side chain. Let's put another carbon in there. It's a little methyl side chain. This doesn't then become pentane. The longest chain of carbons is still only 4. And we've just got now a side chain. We call this is the methyl side chain. We'll have a look at side chains in just a sec, but this will become the 2-methyl butane. Could have actually called this just methyl butane. We'll have a look at that in a bit more detail in a sec. So I'm just going to draw a few more, and we'll see. If you pause the video, you can then try and name them yourselves. So if we go with that compound, and if you pause the video now, see if you can name it. That is ethane. 2 carbons in its longest chain, and they're single bonded to each other. So it's an alkane, so ethane. I'm going to draw all the hydrogens in. Just imagine all the hydrogens around there. Been a bit lazy. If you pause the video now, see if you can name that compound. This will be hexane. 1, 2, 3, 4, 5, 6 carbons in the chain, in the longest chain, so prefix becomes hex. Now we're going to look at side chains. So we can have carbon side chains. So we'll look at 3 different types. So the first one is just a single carbon. We've only got one, it gets the prefix meth, and this is alkanes that have lost a single hydrogen become alkyls. So this is methyl, and it just looks like that. That is CH3, and then it's got an open bond that attaches to the main chain. Ethyl, where we have 2 carbons in the side chain, and propyl, where we have 3 carbons in the side chain. So these can go on the sides of chains, and then we'll put the prefix methyl, ethyl, propyl wherever these appear, whenever we see them. So I'm going to have a look at just a few examples, and we'll name the compounds now using the tables we've just made up. So if you pause the video and see if using your tables you can name this compound. Okay, so the first thing you need to see is that there are in the chain 5 carbons, the longest chain. So this is a pent. We have all of them are single bonded to each other. So it's also, although we've got a functional group, the skeleton is an alkane. I'm just going to make sure that goes on, so I call it pentan. And I've dropped the E because the next letter is going to be a vowel. So I'm going to not put the E on for now. Now we've got here a functional group, which is our alcohol group. We saw earlier that ending, when we have an alcohol group, is pentanol. So this is pentanol, but we can be a bit more specific than this. We can get away with calling it pentanol, but we could have 3 different types of pentanol. We could have it where it's on the first carbon, the second carbon, or the third carbon. So just to clarify where the alcohol group is, this is pentan 2-ol. that we have here. 5 carbons, so pent, all the carbons single bonded, and 2-ol position of the alcohol functional group. Let's try another similar one to this. If you pause the video, see if you can name this compound now. This is bute. 1, 2, 3, 4 carbons. Butane, because they're all single bonded. 1-ol, because they're alkyl groups on the first carbon. So we've got here butane 1-ol. Okay, now we've got slightly different here, a bit trickier. So give this a go and see if you can name this. There are 4 carbons in the chain, and I'm counting the opposite way this time. This side chain that we need a number for, that's going to go on as low a number as possible. So we can count from left to right or right to left. I'm counting right to left in this case because then it gets my chlorine on a lower carbon number. So this is butane, because there are 4 carbons, and this is a haloalkane, so it's a prefix, and this is 2-chlorobutane. 2-chloro lets us know which carbon it's on, and then butane for 4 carbons all single bonded to each other. So I'll give you a chance to answer this one. This is bute 2-ene. There are 4 carbons, and we've got a single double bond between the second and the third carbon. So that 2 here, that's now it comes after the second carbon. I could have numbered either way. On these, it will still come after that second carbon, and then the suffix for an alkene is -ene. Below attached is a worksheet with lots more of these to give you a go at a name. Good luck.